Now here we will create a queue with capacity using Python list, which is called circular queue. So let's get started. So first we will create queue class. Inside init function over here, we will set maximum size for this queue over here, because as we said, we are creating queue this time with the capacity. So max size. So here, the first thing that we are going to do, we will initialize a list with the maximum size. So self items equals to max size multiply with none. As we said before, if we want to initialize an empty list, we need to set all cells to none in case of Python. So now the next thing that we are going to do, we will set the maximum size of the queue to max size that we are receiving from this parameter. Then we will set start and top properties of this queue to -1. So with this, we have created our queue with fixed size. So let's see what's the time and space complexity for this method over here. So if we look at these lines over here, we see that we are just updating the variables over here. So this means that this method will take O1 time complexity. Now the space-time complexity in this case is On, because here we are initializing the items list with the number of elements that we are receiving from max size. So if the max size is n, so the space complexity will be On. Now to make our life easier, I will edit str function over here to print out the queue one more time over here. So this will be the function that we have in previous lecture. So I will quickly just create it over here. Now the next method over here that we are going to create is full method, because in this case we need is full method, because here we have set the maximum size. So if the size of the queue is reached, the full method will return true, otherwise it will return false. So we know that we will use this full method inside the enqueue method. That's why I'm creating full method first over here. So I will declare full method like this is full. It will take as a parameter self. Then here we have two conditions. The first condition is that if, for example, top of the list is before the start of the list, and if we add one element and we are reaching the start of the list, it means that this is full. So I will write this condition like this: if self.top +1 equals to self.start, it means that they don't have any blank list between these variables. So it will return true, saying that it is full. And the other condition is if the start is 0 and top points to the last element in the list, then it means that it's also full. So here I will write like this: start equals 0 and self top, because our index starts from the 0, so we need to add 1 over here, equals to self.max size. So in this case our list is full, so we will return true, otherwise we will return false. So with this is full method is completed. So let's see the time and space complexity for this method. So to see this time complexity, we'll start from here. Here you see that we have only if condition. We are checking top and start variables, so we are returning true. So in this case, this part takes O1 time complexity. Then in the else condition, we are doing again some checking over here. So this is taking also O1 time complexity. And at the end, we are returning false. So this is also O1 time complexity. So if we combine all these complexities over here, we get O1 time complexity. Now it's obvious that the space complexity is O1, because here an additional memory is not required to perform these operations over here. Now let's see how this method is working. So here I will create custom queue by creating object of queue class. So here as a size I will set 3. So the next thing that we are going to do, I will print out the custom queue.isFull. So in this case it should return false, that because we don't have any element in the queue right now. So let's run our code. You see that it returns false. So it means that isFull method works as it should be. Now let's continue to the next method. So the next method is empty method. So here I will create isEmpty method like this. So here we know that if top variable is -1, it means that this queue is empty. So here I will write condition like this: if self.top equals to -1, we will return true. It means that it's empty, otherwise we will return false. Because when we do enqueue to the queue, in this case, we are updating the top variable. So after doing enqueuing, the top value will change. So if the top value is -1, it means that it's empty. Now let's check if this is working correct or not. Here, instead of calling is full, I will call is empty, and in this case it should return true because our queue is now empty. So let's run our code. You see that it returns true, which means that our queue is empty. Now let's see what's the time and space complexity for this method over here. For this method, the time complexity is O1 because here we are just checking if condition, and the space complexity is also O1 because here an additional memory is not required to perform this method over here. Now the next method is enqueue method. Let's see how enqueue method works in the case of circular queue. So here I will create enqueue method like this. It will take as a parameter self and value. Now here the first condition that we are going to do, we will check if this queue is full or not. So if it is full, it means that we cannot insert any element to this queue. So we will return saying that the queue is full. Otherwise, we will continue to insert elements to this queue over here. So inside else condition, we will write like this. If self top plus 1 equals to self dot max size, it means that our top elements points to the last element in the list. So here we will update top to 0. Otherwise, we will add 1 to top to point to the next element in the list. So here we need to take into account that if we are adding first element to the empty queue, we need to update start property as well. So start property has to point to first element, which means that we need to update it to 0 because the first element's index is 0. So if self.start equals -1, it means that this is the first element that we are inserting. So I will set start to 0. Then here we need to add this element to this list. So here we will update it to the value of top. So we know that top points to the next element now. So we will update the value to this blank cell over here. Then we will return saying that the element is inserted at the end of queue. So with this we have completed enqueue method over here. I know that this might be very little bit confusing because here we are just changing the top and start variables. Then at the end we are updating the value of items over here. So to understand this, I recommend you to watch our previous lecture. In the previous lecture with slides, I've explained how this is working. So we have just implemented the logic that we showed there. Now let's see what's the time and space complexity for this method over here. So here we have if condition, which is checking if this queue is full or not. We know that checking a queue if it is full or not takes O1 time complexity. Then in the else condition, we have another two cases over here. So here inside this if condition, there is not any time consuming operation, which means that this part of code takes O1 time complexity. And this means that enqueue method in case of circular queue takes O1 time complexity. And the space complexity for this method over here is O1 also because here we are just updating the blank cell in the Python list. So that's why it takes O1 space complexity. Now let's run our code to see that how this is working. So here, instead of calling is empty method, I will call enqueue method. I will enqueue 3 elements over here. Then I will print out our custom queue over here. So let's save and run our code. You see that first we inserted this element, which is 1. Then we enqueued 2. Then we enqueued 3. So as you see, when we enqueue the elements, it's enqueuing at the end of list over here. Now if run is full method over here now, it will show that the capacity is reached and it's full now. So let's run our code. You see that now it returns true, which means that we have created custom queue with the capacity of 3 and we have inserted 3 elements. It reached the capacity of the queue over here, which means that our queue is now full. Now let's continue to the next method. The next method is dequeue. So here I will create the queue method over here like this. So it will take default parameter self. Then the first thing that we are going to do over here, we will check if the queue is empty or not. So if self dot is empty, we will return saying that there is not any element in the queue. Otherwise, we will dequeue the element from here. So else. So we know that in case of dequeuing elements from circular queue, we are updating the value of start and we are returning this value from here. So here, the first thing that we are going to do, I will create temporary variable over here to return this one. So first element is equal to self dot items, and we know that the first element is the one that the start property points. So here I will put self start. Then I will keep the start value. So start is equal self start. Then inside if condition, we will check this condition. If this is the only element that we are dequeuing from the queue, in this case, we need to set start and top property to -1. So if self start equals self top, it means that this is the only element in the queue, because in this case, both of them will point to the first element. So in this case, we are updating the self start to -1 and self top to -1, because this is the last element in the queue. So after this, we will not have any element in the queue. It means that our queue is empty. Then in the else condition, elif condition, we are checking if the first element points to the last element in the list, then we are pointing it to come to the, again, at the beginning of list here. So here I will set self start +1 equals self dot max size. Then we are setting self start to 0. In the else condition, we are increasing the self start every time by 1 to point to the next element in the list. Then at the end, we are setting self item start to none, because after returning the first element, we need to ignore this. So to ignore this, we are setting it to none. So at the end, we will return first element, because here we kept the first element. So with this, we have finished our dequeue method. Now let's see what's the time and space complexity for this method over here. And it's obvious that the time complexity is O1, because here we have just created two variables and updated the values. And in the if condition, we are just updating start property and top property. And there is not any time consuming operation over here. So which means that it will take O1 time complexity. Now the space complexity is also O1, because here we are just creating two variables and updating the values. And any space consuming operation is not doing over here. So which means that it will take O1 space complexity. Now let's see how this is working. After enqueuing here, if I run dequeue method, it's obvious that it will return 1 in our case. So if you save and run our code, in this case you see that it returns 1. Now after dequeuing, if I print out custom queue, you will see that 1 is removed from the queue. So you see that the first element is none, and then 2 and 3. So which means that when we have none, we are ignoring this element. The first element here is 2. Let's continue to the next method. So the next method is pick method. So here I will create pick method like this. So we know that in case of pick method, we are just returning first element from the queue, but we are not deleting an element over here. So here, the first case that we are going to do, we will check one more time if this list is empty or not. If it is empty, it means that we don't have any element to return. So I will copy this case from here and put it here, because it looks like the queue method. So in the else condition, we will return self items, and we know that the first element is the one which is the start property point. So here I will put start. For this case, for example, after dequeuing, if we run pick method, it will return 2, not none. So let's just clear this. If I run it, you see that when we dequeue, it returns 1 and 1 is removed. When we call the pick method, it returns 2 over here. It's obvious that the time complexity for this method is O1, because in this case, we are just accessing the element of the list, and we know that accessing an element of the list is O1 time complexity. So it's obvious that the space complexity is also O1, because accessing an element of list is not requiring an extra space. So that's why it takes O1 space complexity. Now finally, the last method is delete method. So in this case, we will delete all elements from the queue. So I will declare our delete method like this. So here we will set all elements of items list to none, and we will set top and start variables to -1. So self items self dot max size multiply with none. So we are setting all elements to none, and self dot top equals -1, and self dot start set to -1. In this case, our queue becomes empty. Now let's see what's the time and space complexity for this method over here. So here we are just updating the elements of the list to none. So it will take O1 time complexity, and the space complexity is also O1, because here an additional space is not required. Now let's see how this method is working. So in this case, I will call delete method, then I will print out our custom queue. So let's save it and run our code. So here you see that it shows only none, 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 which means that we don't have any element in this queue over here. Now we have completed all methods that are related to circular queue over here. Now let's combine all these methods together to see the time and space complexities for these methods over here. Now here we have combined all methods of circular queue to see the big picture of time and space complexities of these operations over here. Now the first method is create queue. We know that in case of circular queue, when we create a queue, we are initializing fixed side of list. So this takes O1 time complexity because here we're just creating a list. Now the space complexity will take On because in this case we are initializing n number of the cells and we are setting them to none. So here n is the size of the queue. That's why it takes On space complexity. Now the next method is enqueue method. We have learned that in case of circular queue, when we are doing enqueue to the queue, we are accessing the elements in the list and updating them. And we know that accessing elements in the list takes O1 time complexity, so updating them also takes O1 time complexity. Now here, the space complexity is also O1 because in this case, we don't need any additional space. The next method is dequeue method. So dequeue method also works with the logic of the enqueue method. Here we are just updating the cells of the list and we are updating one variable, which is start variable. That's why it takes O1 time complexity. Now in this case also space complexity is O1 because here we are just updating the element of list. Now the next method is pick method. We know that pick method returns the first element from the queue. So in case of Python list, when we access the first element, it takes O1 time complexity. That's why here returning first element from the queue takes O1 time complexity. And we know from the list section that when we access the element of list, it takes O1 space complexity. That's why here also it takes O1 space complexity. Now the next method is empty method. So in case of circular queue, to check that if the queue is empty or not, we are checking top value. If top value equals to -1, it means that this queue is empty, otherwise it's not empty. So in this case, we are just checking top variable. That's why it takes O1 time complexity. Now the space complexity for if condition is also O1. Now the next method is full method. Here inside full method we are checking 3 different conditions. That's why it takes O1 time complexity because here we have only if condition. We are not doing any extra operation that might take much time. That's why this takes O1 time complexity. And the space complexity is also O1 because in this case we are not doing any space related operation. Now the last method is delete entire queue. So in this case we are setting the list to none. That's why it takes O1 time complexity. Now the space complexity is also O1 because in this case we are removing the all elements from the list. Now this is all for this lecture. So in this lecture we have implemented circular queue operations and we have learned what is the time and space complexity for these operations over here. Now in the next lecture, let's create queue using linked list. See you in the next lecture.